Hello everyone, welcome to 5 Minutes CS Talk. For this video, we will discuss how to transfer VTK objects between different processes. And this is also a case study to show how to design a scalable communicator. Let's go through VTK object quickly, in case that you are not familiar with this kind of data type. Before discussing about the VTK object, it is worth to mention a data type called mesh. Intuitively, if we want to manipulate a large amount of data, we tend to divide this huge amount of data into particular unit and manipulate every unit. A simple example is the pixel in an image. An image is composed by multiple pixels, and every pixel is a small square. We can manipulate particular pixel to achieve associated effects, such as making the whole image look brighter or darker. In the context of the image, basically every unit in the whole data domain is a small square with same size. Similarly, the unit can also be polygonal or the rectangular with different size in different contexts. And the mesh data is used a lot in discrete data processing. Common using contexts include computer vision, computer graphics, or numerical simulation. VTK, namely the Visualization Toolkit, is a widely used library to process the mesh data, and the VTK object is a representation used in this library to describe the mesh data. We list typical mesh types that can be described by VTK objects here. What if we want to transfer a VTK object between different processes or between client and server? In order to do some operations such as the data aggregation or broadcasting, how will you design interfaces such as data put and data get based on existing libraries? Let's look at a real example here. In this example, we show how to transfer VTK polygonal data between two MPI processes based on the data transfer interface provided by the VTK library. The interface is quite simple actually. We just need to initialize a vtkMPIController and then call the send API at the data sender, such as a rank 1 process, and then call the receive API at the receiver, such as a rank 2 process in this example. The interfaces shown here are quite similar to the MPI send and receive primitive. The difference is that, for this case, the parameter is complicated VTK object instead of the raw array used in the MPI interface. What is the gap between the MPI primitives and the high-level VTK object primitives? In your applications, you may need to do similar things to transfer a customized data object between client and server. How will you design the high-level interface based on the low-level libraries such as MPI send and receive? Let's see how VTK library do this. It uses several classes to achieve this capability. The basic one is the vtkMPICommunicator. This class wraps the necessary MPI interfaces used by the VTK library, and the input parameters are basically same with the raw MPI primitives. The second class is called the vtkMPIController. This class wraps the vtkMPICommunicator, and it manages the life cycle of vtkMPICommunicator, such as creating, deleting a communicator. And this controller class may contain multiple communicators for different goals in application. For example, some communicators may aim at transferring the control information, and other communicators may aim at transferring actual data. Here comes an important design strategy. How to design the abstraction based on concrete class, since in actual application, we may hope to support different backends such as MPI, socket, or other customized library to transfer the data between different devices. How to design a proper abstraction for this capability? In the VTK library, the first abstraction class is called the vtkCommunicator. This class provides functions such as marshalling a VTK object into a string and a marshalling string into a particular VTK object. Basically, the vtkCommunicator is a bridge between the underlying communicator implementation and the high-level data representation. By this way, the concrete implementation such as vtkMPICommunicator can implement the interfaces specified in the vtkCommunicator without worrying about the data type. For the high-level algorithm that uses the data transfer, it just calls the interface specified in the vtkCommunicator without worrying about the underlying implementation for data transfer. So, by this class, we could decouple the data transfer implementation and the data representation. Similarly, the vtkMultiProcessController includes several vtkCommunicator, and it can use these communicators to achieve different goals, such as remote function call or data transferring. With these abstraction classes, such as vtkCommunicator and vtkMultiProcessCommunicator, if we want to add new low-level communicator implementation, we just need to add more concrete examples similar to the MPI version without changing the code of the high-level algorithm layer. Hope this design strategy could provide some insights for you to program your software. Thanks for watching and see you next time.